going to do is learn how to complete the unit circle. The unit circle is the basis for all circular functions and all periodic functions, analysis of anything that's cyclical, like business cycles or population of wild animals or things like that. So the idea is we're going to be able to do this all by ourselves. Now, if you just memorize it, there's really too much to memorize, and it's too confusing. So let's start by saying that the unit circle is a circle with radius 1 centered at the origin. So the unit circle is a circle with radius 1 centered at the origin. So here we go, a circle, radius 1, centers at the origin. So I can fill in these points. If the radius is 1, that's 1, 0. This point is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. I also need to tell you that we measure location on the unit circle by angles, and we measure counterclockwise from the positive x-axis. So right here is at 0 degrees. Right here, we've traveled through 90 degrees. Over here, we've traveled through 180 degrees. And down at the bottom, 270 degrees. Okay. Now, there are two triangles that we're going to use with the unit circle. And here are pictures of both of them. You'll see that these are right triangles, and the hypotenuse of this triangle is 1. This is also a right triangle, and the hypotenuse, the longest length, is 1. Okay, so let's just do a little bit of analysis of the length of the sides of these triangles. Let's take the blue one first. Okay, if I look carefully at the blue triangle, I'll notice that my legs are the same side. I also know that the hypotenuse is 1 and the legs are the same side. So let me draw this right triangle. Hypotenuse 1, legs the same size. Now that, excuse how rough it is. Okay. If the legs are the same size, it's called an isosceles right triangle. So these two angles are the same, and therefore these angles have to be 45 degrees. Because if you have two angles that are the same in a right triangle and a triangle, the acute angles have to be 45 degrees. Now I'm going to find the length of the legs using the Pythagorean theorem. And the Pythagorean theorem says the sum of the squares of the legs equals the square of the hypotenuse. So the legs are both x because they're the same length long. The hypotenuse is 1. So x squared plus x squared is 2x squared, and 1 squared is 1 times 1, which is 1. So x squared is a half. So x is the square root of a half. I don't have to worry about the negative square root of a half because it's the length of the side, so it has to be positive. Now, we don't like fractions under square root signs, so I'm distributing it across the divide. So x is 1 over root 2, and we don't like radicals as denominators, so the exact length of these sides are root 2 over 2. So this side is root 2 over 2, and this side is root 2 over 2. And just for, just to know, root 2 over 2 is a little bit more than 0.7, but we never use a decimal. We always use the exact value, root 2 over 2. So now let's see how we can use this to complete our unit circle. Okay. This triangle fits in here. It takes us to this point on the unit circle. So the angle that I've moved through from 0 is 45 degrees. And the coordinates at that point are the lengths of the side of this triangle. Root 2 over 2 over and root 2 over 2 up. Okay, I can do another point right here. This is through 90 plus another 45, which is 135. I can also think of that as 180 minus 45, which is also 135. And the sides of the triangle are exactly the same. I've just gone backwards. So I've gone backwards, root 2 over 2, and up, root 2 over 2. Okay, third one. It'll be in my third quadrant. We're right here. This is at 180 plus 45, which is 225 degrees. The lengths are the same. It's just the direction that changes. Root 2 over 2, root 2 over 2. And I go backwards and down, so they're both negative. Okay, last one with this triangle. Right, takes us to this point. We're at 270 plus 45, that's 315 degrees. Our lengths are the same, root 2 over 2, root 2 over 2. We go forward, so that's positive, and we go down, so the y is negative. And now I've got 4 points on my, 4 more points on my unit circle. It's the midpoint of each quadrant. The x-coordinate and the y-coordinate have the same absolute value, the same size, and it's the one with the numerator and denominator that I'll go to. All right, let's stop for that for a break.